Welcome to our 7th physics lesson, Form 4, where I will be taking you through thin lenses. On the objectives of our lesson today, we are going to determine the focal length of a lens using the lens formula. And first, I shall begin by taking you through the experiment and demonstration in which you're going to determine the focal length using the lens formula. Of a thin lens, you're going to use the apparatus, and the apparatus should be arranged as you can be able to see. We have the source of light, which is our candle. The source of light penetrates through the softboard with cross wires. Then the arrows are showing us the rays of light. The rays of light are being magnified on the lens so that they concentrate at a given point on the screen. On our screen, we are going to obtain a sharp image. So I want to take you through this experiment so that we can be able to determine the focal length. So here with me, I have the apparatus. This is the softboard with cross wires. These are the cross wires. We also need a lens holder. We have a lens holder which is used to hold the lens. At this point, I have a magnifying lens. It is usually held like that on a lens holder. In the same experiment, we also need a white screen. That is my white screen. Okay, apart from the white screen, we have the meter rule. This is the meter rule. That is measuring 100 centimeters, which is equivalent to 1 meters. We also have a source of light, which is a candle, and together with the candle, I have my matchstick, so we can go to the experiment. So you're going to arrange your experiment like that, so that at the end of the meter rule, you have your screen. Looking at the figure in the middle, you have a lens with a lens holder. You have a softboard with cross wires or a cardboard. Then on a cardboard with cross wires, I'll place my candle behind that cross wire. And then after that, I'm going to light my candle. I'm lighting my candle there, which is the source of light. So I want to use this candle, which is our source of light, in order to get the image of that light on the screen. So you are told to adjust, you're supposed to adjust the candle, and my candle should be bright. It is not yet bright. I want us to have it bright. Okay, so I want us to obtain the image of this candle on the screen by adjusting the distances here. So until I obtain the very sharp image on that screen, so you can be able to see the image of that flame on the screen. So the image of the sharp flame on the image of this on the screen is what we are being guided on our diagram. So what are we supposed to do? Looking at here, we have the distance between my source of light and the lens. This distance here is called U. So U is the distance between the object and the lens. Then we have the distance between the lens and the screen. This distance is known as V. So you can be able to obtain different values of U and V by adjusting the screen. You can be able to see me adjusting that screen. So when I adjust the screen, I also adjust my image. You can be able to see. I want you to look at that image. So looking at that image, you obtain a sharp image. So through the adjustments of the distances of U and V, we can be able to record the different values of U and V. And from the table, we can use these values to plot the graph of 1 over V against 1 over U. Determining obtain the values of V and the values of U with their corresponding values of 1 over U and 1 over V. So Having these values, then we can use the values of 1 over u and 1 over v to plot the graph of 1 over u against 1 over v. So from the image, you can be able to see the graph. On our graph, we have plotted the value of 1 over v against 1 over u. This graph is giving us a straight line which cuts through both the axes. It cuts through the axis of 1 over u, and it also cuts through the axis of 1 over v. Therefore, we can be able to use this graph to determine the focal length of the lens in which we have been able to use in our demonstration. How can we be able to get the focal length? From the graph, you can be able to find out that the intercept of 1 over u is equivalent to 1 over f. The intercept on 1 over v is also equivalent to 1 over f, meaning that the intercept on 1 over v is equivalent to the intercept in 1 over u. Therefore, we can also have another case where the two values are not equal. That is the intercept of 1 over u and the intercept on 1 over v. In this case, we usually find the average of the two values to give us the value of 1 over f. 1 over f represents the reciprocal of the focal length, and therefore we can be able to determine the focal length of that lens. After having looked at that, we shall also look at the little quiz. This is the assignment that we can be able to look at after the lesson. And on our assignment, question number 1, we are told, state the lens formula. State the lens formula. And number 2, explain how you can use the lens formula to determine the focal length. Explain